35,000, again, that is the number that you want to test. You know, that's like a just thinking that is a focus point that we want to test, right? The criteria that we want to test, or the specific value that we want to test, which is the specific value that we want to test, which is the mu sub 0, right? So again, basically, again, this is the specific number that we want to compare to, okay? We don't want to compare to my sample mean, right? We don't want to compare to the standard deviation. We only want to compare to basically what do they ask us to compute, right? So again, if you have this thing here, hopefully now you say, oh, I can state the hypothesis, which is looking at this thing here. The null hypothesis is the dummy hypothesis where they can only hold the equal sign, which is in this case, H sub 0 is mu equal to 35,000. And now what do they ask me to do? Which is they ask me to verify or conclude that is different. Again, they are not asked to compute if it's less than. They're not asked to compute if it's greater than. They just want to know if the price is different from the 35,000, which is different. Tell us that it's a two-tail test, which is not equal to, right? Not equal to tell us two-tail. So that is your hypothesis testing, right? Your hypothesis, not hypothesis testing, state your hypothesis. Now, they ask you to compute the t statistic, which is, again, that is a given, right? If they ask you to compute a t statistic, meaning we know that we need a t distribution or a t critical value. But again, reminder, this is your t statistic testing, which is x bar minus mu divided by s all over square root of n, which is, again, do you agree that we have everything we needed, which is x bar is this one, mu is this one, s is right here, and the n is right there, which is, again, I have everything I needed, which is I can just plug this thing in my calculator and calculate like I have before. Or you can use your calculator and use your t-test, right? We know that they ask us for t-statistic testing, which is we know that it's a t-distribution. And if it's the t-distribution, we know that is we're using the t-test feature. And the t-test feature tell us, that if you do this thing here, on your t-test, you will have 1.5071. Or if you plug this number in your calculator, you will get that number too. And they ask you how many degree of freedom are there, which is degree of freedom is n is 14 minus 1. So again, looking at this thing here, if some of you guys ask me, say, Mr. Tran, don't we need to have more than 30 data for us to do all this thing here? We do, right? We do need more than 30 data. But since we don't have more than 30 data, everybody see that they mentioned this to us, right? They mentioned that the population is approximately normal. So again, we have a bypass, right? They tell us that it's approximately normal, so we know that we are safe to go, safe to test, so we can do it. Okay, so again, yes, we need it. The previous problem is 76, so we don't need that normally, approximately normal, right? This one here, because the data is smaller than 30, so we need that to know that they are normal so that we can use that bell-shaped t distribution curve. Okay, so once we have this thing here, one thing I want to mention is, looking at this item, state your conclusion. State your conclusion, which is, there are two ways to state your conclusion, which is, one way is using this sketch, right? You sketch this normal distribution curve. And ladies and gentlemen, looking at this thing here, to sketch this thing here, we have two tail. That's why we have the left tail and the right tail. That's why we have two tail. We need a critical value. But the critical value we need is we need a t critical value. So looking at this thing here, I want to point out and make a note for yourself. First of all, ladies and gentlemen, the alpha that they give us, is 0.01. That's the alpha they give us. But that will not be the alpha that we're looking for. Why that is not the alpha we're looking for? The reason is this, ladies and gentlemen. If it's a one tail, then yes, that's the alpha we're looking for. If it's a left tail or right tail, that's the alpha we're looking for. But because it's a two tail, Because it's a two-tail, we need to take this alpha and divide it by 2. Because we have a left and the right tail, we have to take the leftover and divide by 2, which is the alpha that I'm looking for is this right here, ladies and gentlemen. If you take 0.01, 0.01 divided by 2, you will get 0.005. Okay, so if you take 0.01 divided by 2, and why, excuse me, why do we divide by 2? Is because we have a two-tail test. Okay, so this is the alpha we're looking for is 0.005, not the 0.1 that they give us. Just because we have a two-tail test, we have to divide that alpha, and because we have a two-tail, it's an alpha over 2. So this is the alpha we're looking, which is again 0.005. The degree of freedom is 13 because we have, no, not 13. Yeah, 14 minus 1, right? We have 13, which is everybody see that this is my critical value here. My critical value is 3.012. Again, go back to the concept or go back to the item is they give us 0.01 as an alpha, but because it's a two-tail test, we need to take that alpha and divide it by 2. And that is why I'm looking at the column of 0.005 and not 0.01. And that is why my critical value is negative 3.02 and positive 3.02 because I have a two-tail test. And once I have this thing here, I know my boundary. I know that on the left side and on the right side, those are my reject region. And in the middle will be the fail to reject region. And again, look at this thing here, my t-test. You did the t-test here. Where is 1.5? Is 1.5 to the left of 3 or on the right of 3? Which is hopefully you guys see that it's on the left of 3, right? It's in the middle right here. 1.3 is somewhere in there, right? Somewhere in that nature, right? That's where 1.5 is, right? Which is again, is in the do not reject region. And if you look at your p-value, right? If you look at your p-value, you can see that your p-value is bigger than the alpha, right? I did not write a p-value here, but I think the p-value is like 2 something. But the 0.2 something. The p-value is bigger than alpha, way bigger than alpha, which is again, if the p-value is bigger than alpha, we do not reject. And if we do not reject H sub 0, we say we do not have enough evidence to support that the private entity is different from 35,000. So basically, the private entity mean the average price of the private entity is the same as the normal. If this is the sample, the mean of the population of all college in California. Okay, so again, looking at this thing here, we just say we don't have enough information. Let's collect more data. For now,
real quick.
Yes.
I have a quick question. If we're going to use the p-value to compare to the alpha, when we do we still need to divide by 2 when we're using the two-tail and compare the p-value divided by 2 or the normal alphas that was given to us?
Just the normal alpha. You just compare to the normal alpha. For the p-value, you only compare to the alpha itself, not the alpha over 2.
Oh, okay. I was
Yeah.
just clarifying.
Right. The only time, the reason why we do the alpha over 2 is when you find a critical value. Okay, so the alpha over 2 is only when you use it to find your critical value in your table. So not when you compare the p-value versus the alpha, you only compare to original alpha. Whatever alpha they give you, that's the alpha you compare to. Okay. So question with this particular problem, which is again, the step, the procedure, and the outlook of the problem is very similar to 8.2. And the only thing different is we're using the T versus the Z. And how do we know to use the T? Because we have a sample standard deviation. We don't have the population standard deviation. Okay. So let's try one more. If you don't have question with this one here, I think a few of you guys sent me a question in chapter 7 relate to something like this problem. The one thing I want to point out that the 7.1 problem, for this kind of problem, they give you some of the problem, they give you the sigma, they give you the population standard deviation. So even though they give you the raw data, like this particular problem, even though they give you the raw data, but if they give you the sigma, the population standard deviation, you still have to use the Z confidence interval, or in this case, if this problem were to give you the sigma, then you still have to use the Z test. Okay, that's the main difference. The one thing that they want you to understand is, if you have somewhere in the problem, if they give you the population standard deviation, then you have to use the Z test, the Z confidence interval. If you scan through this problem, if you scan this slide and you say, nope, they don't give me any sigma, they don't say anything about population standard deviation, so hopefully that you see that, okay, now we have to use the T, because everything that we have up here is related to a sample item. Okay, so looking at this thing here, how much is in that can? So a machine that fill a Peplush, which is, again, let's say a machine that put in the Coke, right? The can, the 12-ounce Coke. And this Coke, they fill in 12 ounce, and they want to measure, is this machine fill in the right amount, right? So they take out the A can, we have, which is this, the A raw data. Some can have 11.96, some can have 12.04, and so on and so forth, right? And now they give you this dot plot, and they ask you, given this dot plot, is it okay for us to perform the hypothesis test, right? So looking at this thing here, as you can see, the data is very close together, right? It's 0.9, every time it's 0.05, every time we jump is 0.05. So looking at this thing here, we don't have any extreme outlier, right? Meaning we don't have any data like 18 ounce, or we don't have any like 6 ounce, like something in extremely, in terms of looking at this thing here, we know that we can use it because they all closer together, meaning if we get more data, then this data tentatively will become a normally distribution or normal data, right? So now we know that, yes, we can use it. We can use the hypothesis testing because there is no outlier, there is no mole, like there's no 2 mole, right? We don't see any mole, and we don't see any skewness, right? We don't see anything shift to left or shift to right. It's kind of balance them out. So looking at this thing here, this is what they ask you is, if it's appropriate to do it, can you calculate, or can you, what is your conclusion, right? So again, perform a hypothesis to determine whether the mean volume is different from the 12 ounce. So again, looking at this thing here, what is your hypothesis testing? Well, not your hypothesis testing, but what is your null hypothesis and your alternate hypothesis? So do you agree that we want to know if they are different from the 12 ounce, right? This is what they want is, can you verify whether or determine is the volume is different from the 12 ounce, which is, that is your claim, right? Your claim is right here. You want to claim that the mean is not equal to 12, different from 12, right? And again, given that, that will be your two-tailed test, okay? So now, ladies and gentlemen, look at this thing here, which is, again, my null hypothesis and my alternative hypothesis. Now, looking at this item, one thing is, if you have a raw data such as this, if you have a raw data such as this, and if you want to tell your calculator to do it, you have to edit your data, meaning you have to put your data in your L1, right? Meaning, again, all I did was whatever my data, which is 11.96, I put in my data 12.1, so on and so forth. I put the A data I have in my L1 column, okay? Because I don't have, if you look at this thing here, they don't give me the population mean, they don't give me a sample mean. Well, they give us population mean, the specific value, right? They don't give us a sample mean, they don't give us a sample standard deviation. All they do is they give us the raw data. So if they give us the raw data, we can do it, we can calculate it. We just put our raw data in L1. And then when you come to your testing, just make sure that instead of choosing the stat item, instead of choosing the stat information, you just tell your calculator, I have the data in L1. Go to L1 and take that data and use it, right? So now what is your mu sub 0? What is the specific value that you want to calculate? Well, we want to calculate if it's different from the 12 out can, right? Which is, again, that is your item, your list, which is you tell your calculator, my list is in L1, go ahead, go to L1, take those items, and make sure that you choose then, make sure that you choose in your two-tail test. We have a two-tail test here and not a left tail or a right tail. We have a two-tail, and then you tell your calculator to calculate it for you. And again, this is the two output that we want. We want the T, which is 0.9725, right? That's your T value, 0.9725. But we don't really need a T if we have a P value, which is the P value is 0.36, right? So everybody see that looking at this thing here, because they only asked me to tell my conclusion, they don't tell me about that critical value or anything. Well, I can just say my P value is 0.3632. which is the p-value is bigger than my alpha, humongously bigger than my alpha, right? Which is the p-value is greater than the alpha, which is the result is we do not reject the H naught. And if we do not reject H naught, we just say we don't have enough evidence to say that the weight or the volume is different from the 12-hour can, okay? So again, this is the idea, which is your calculator can do it for you. If they were to ask you the critical value, reminder, the critical value, the alpha is 0.05. The 0.05 is right here, but reminder that you have a two-tail test and you'd have to take 0.05 divided by 2, which is this is your item that you need to look at. If you take 0.05 divided by 2, you get 0.0225, right? You get 0.025, which is, this is the number, because we have two-tail, we have to divide the alpha by 2, which is, this is what we have, which is, everybody see the critical value is negative 2.20 and positive 2.20. And if you remember my number, you know, if we have a negative and positive, my number is like 0.9 something. 0.9 something is inside here, which is, if it's inside here, it's in the do not reject region. And it's the same process at this thing here. I did not do that because I have my p-value. And if I have my p-value and they don't ask me for my critical value, I don't need to. I just want to show you that you can find your critical value too, okay? But again, this one here, because they ask you what is your conclusion, you can just state your p-value and say your p-value is greater than your alpha, so we do not reject. And since we do not reject, we don't have enough evidence to whatever they want us to support, okay? So again, I want to give you guys this problem because, again, if you were to run into this problem where they give you the raw data, you have to plug in your raw data and tell your calculator that you have the raw data. Go ahead and take the raw data. I don't have the statistic information. I only have the raw data. Take that raw data and calculate, okay? So first of all, question with this particular problem, how we, which feature to use. Again, the t-test feature, we use in the data, and then we use in the L1. We put in our data in L1. So again, question here. So perfect, Tom. If you don't have question, let's take a look at 8.4. I just want to show you 8.4 to show you that 8.4 is the same pattern, the same item as 8.2 and 8.3, okay? So 8.4, what is the difference between 8.4 versus the other two? We have to do the hypothesis testing for the proportion. So if they actually find the proportion, we're doing the proportion, which is 8.4, which is, as you can see, the notation is the same as before. The notation is, again, last time we have the point estimator. This time we have, again, population proportion is your P. The X bar is the number of people who say, yes, we accept, we agree, whatever the successful rate or successful item. And the N, as always, if by now, hopefully you know that in this class, the N is always the total of something, right? And again, now your P hat, which is your sample proportion, okay? And the P hat is basically the X divided by N. Remember, P hat is X divided by N. We need that in a bit, okay? So again, this method is the same as before, which is we need the random to be, it's sample and have to be random. We need the population have to be more than 20. And we need to have two category, which is either yes or no, right? And then we need that this number have to be bigger than 10, like the N times the P have to be bigger than 10, and 1 minus P times N have to be bigger than 1. So this 4 item have to match in order for us to do this proportional test. And again, looking at this thing here, as you will see right here, this is the steps in 8.2. And again, this is 8.4. I did not change it. It's still 8.2. But again, 8.4 here, as you can see, 8.4 and 8.2 and 8.3, the step is the same. The step is the same in a way that, again, the first you have to state your hypothesis. Step 2 is you have to find your critical value, which is your level of significance. They give you the level of significance. You have to find your critical value. Step 3 is you have to do your test. In 8.2, you do that z-test, which is the X bar minus the mu divided by the sigma over square root of N. 8.3, you have the t-test, which is the X bar minus the mu divided by the S over square root of N. And now in 8.4, we have this Z proportional test, which is the P hat minus the P all over square root, which is this is the same formula that we use in chapter 5 and in chapter 7. Okay, so once we have this thing here, don't worry about this left and compute the p-value. Most of the time or always you will use your calculator to find this p-value. Okay, and then again, interpret your p-value or your critical value and make the decision, and then state your conclusion, which is this 6-step or 5-step is the same all throughout chapter 8 except 8.1, right? 8.1, we only have step 1 and step 6, which is state and then conclusion. Okay, now we have to do the me part. So let's take a look at this example here. Let's take a look at this example. And again, if you look through this example or you scan through this example, you can see that the information they give you are different from the previous 2 problems or the previous 2 sections, right? And also they ask you this, they ask you, can you conclude that the proportional, right? So when they ask you for a proportion, which is again, that's the keyword that we have to use, a proportional or the one prop z-test, as you will see in a bit, okay? So look at this thing here. Again, in a recent Gen X2Z American College Student Survey, 90% of the female college students rate the social network site Facebook as cool. Assume that the survey was based on a random sample of 500 students. A marketing executive at Facebook want to advertise the site with the slogan, more than 85% of female college students think Facebook is cool. Can you conclude that the proportion of the female student who think Facebook is cool is greater than 0.85 using the alpha of 0.05? So looking at this thing here, if you stuck, right? If you stuck, you just go in here and identify what are my number. What are the number that they give us, which is again, looking at this thing here, the slogan is the same as this item. So again, if you go in here and you just block out all the wording, right? Block out all the wording and just focus on the number. And if you focus on the number, hopefully you see that obviously 500 is easy to spot, which is that is your total sample, that's your N, right? So now the alpha should be easy to spot. The alpha is just the alpha, that's your level of significance, which is your probability of type 1 error, right? So again, those two is easy to spot, and that's what happened in 8.4 is those two items is easy to spot. The other thing is hard to spot is if they give you the percentage or they give you the X. So looking at this thing here, remember I told you that we have two percentages here. Which one will we use to compete to test, right? Which one are we using as a specific value? And I mentioned to you guys, what do they ask you to do? Well, they ask you to conclude that the proportion of female is greater than this specific number. So this right here, the 85 is your P sub 0. We use the P sub 0 because we're in a proportional or a proportion. Last time we used the mu sub 0 because we're in the mean. The mu sub 0 is the specific mean that we need to compute. This one here, the specific P that we need to compute is 0.85. We want to know if this number is greater than 0.85. And that left us with the 90%. What is this 90%? Well, the 90% is, ladies and gentlemen, is the sample of the female, right? The survey, which is survey related to a sample. If you remember chapter 1, survey is your statistic number. So 90% of the female, which is in the survey, 90%, right? So looking at this thing here, this is what we have is the P hat is equal to 0.9. So that is what we need to do, or that's what you need to do, because the next item is very doable or similar to before, which is we need to state the hypothesis. So once you know your specific value, your hypothesis is P is equal to 0.85. And P is greater than 0.85, which is because they asked us for a greater than item. And again, if it's greater than, we know that this is the right tail test, right? A right tail because it's point to the right. And now what do we need to do? Well, we need to use a calculator to find the z-test, or to find a critical, not the critical value. You have to use the table you use to find a critical value. But again, looking at this thing here, if you use your calculator, which most of you after this will use your calculator, this is what you do is you hit stat, same way as you do the other one, and you go to test. And all you need to do is, ladies and gentlemen, go down to number 5. Your number 5 is one prop Z test. So again, in this test menu, right now on the screen, there are 6 items that you using in this item here. You use the Z test for 8.2. You use the T test for 8.3. You use the one prop Z test for 8.4, one proportional Z test. And again, if you go down, you have the Z interval, the T interval, and the one prop Z interval. So there are 4 items on this screen that you will be using on this test. The challenge for you is to determine which one to use. So again, the test and the interval is easy. If they ask you to construct the interval, that's what you're going to use, the interval. If they ask you to conclude, right, then that's your test. And again, the T versus the Z is the T sample standard deviation, the Z population standard deviation. And if they ask you for proportional, we're using the one proportional Z test. So looking at this thing here, if you type this thing in, you need 3 items here, ladies and gentlemen. If you type this thing in your calculator, you need 3 items. You need the N, which we got. We need the P sub 0, which we got. And we also need a X. And if you look at this thing here, if you reread the problem, you say, oh, they don't give me an X value. There's no X value here, right? So looking at this thing here, there's no X value that we have at all. So if we don't have an X value, what do they give us? Well, looking at this thing here, I told you guys to remember this thing earlier, that the P hat is equal to X divided by N, which is that's P hat. They give us the P hat. Can I find the X? Which is, do you agree that I can multiply the N over to give me X by itself, which is one algebraic expression, which is, again, I multiply the N over, I have X equal to P hat times the N. Do I have the P hat? Do I have the N? Which is, hopefully you guys see that the P hat is 0.90. That's what they give us. The n is 500, which is, again, I can multiply them. I can use this algebraic expression or the formula to find that my x is equal to 450, right? So now I got the three items I needed. I need an n, I need a p sub 0, and an x. So if I got the three items I needed, I can use this calculator, which is, if you go to your calculator, which is, again, the p sub 0 is 0.85, the x is equal to 450, the n is equal to 500, and again, make sure that you choosing the right tail test, which is, again, this is your right tail test here. And if you go down to calculate, which is, everybody see that this menu, you need a p sub 0, you need an x, and you need an n. And the only reason why I have to maneuver my formula is because the problem does not give me an x. If the problem give me an x, life is good. But in this case, it's a little bit rough, right? Life never too smooth, right? So again, look at this thing here. You click on calculate. And again, this is what you have, ladies and gentlemen. You have a z 3.13, and you have the p-value 8.7076. So again, if you look at this thing here, if we were to have a critical value, which is a critical value, we use a z critical value. If we were to have a critical value, you will see that, again, this number, the critical value is 1.645, and 3.13 is on the right of that, which is the result is we reject the h sub 0, okay? So one thing I want to point out, this thing here, most important thing before I let you guys go is, make sure, ladies and gentlemen, your p-value is 8.7076, whatever, e to the negative 4. So do not, please do not do this on your homework, on your test, or on whatever you do. Do not say, oh, 8.7 is bigger than 0.05. Because of the e to the 4, e to the negative 4, this is basically, technically, relatively, right? This is what we need to do, is we need to, because of the negative 4, we have to move the decimal 3 or 4 places to the left, which is your p-value is actually 0.0008707, right? So looking at this thing here, this is the actual p-value. Your calculator does not want to write the small number. That's why they put e to the negative 4. And remember, your p-value is always a decimal, right? Your p-value is the probability of something, and if the probability of something is will always be in decimal. If you see that 8.7, you did something wrong, right? Unless there's an e to the negative 4. So looking at this thing here, don't jump the gun and say, oh, 8.7 bigger than alpha. I do not reject, right? Again, actually is very small, right? 0.006 is smaller than the alpha. So looking at this thing here, if you do your critical value, and I mentioned the critical value, we go back to the z because it's a proportional z test. So we go back to the z, the alpha is 0.05, so the z critical value is 1.645, and again 3.131 is somewhere here, which is in the reject region. Or if you look at your p-value, you can see that the p-value is way smaller than the alpha. We reject, right? And again, if it's we reject, we say that we have enough information, we have enough evidence that the proportion of the female college who think Facebook is cool is greater than 85%. Meaning if they post a slogan, you cannot sue them, and you cannot say, oh, you tricked me, you lie with the number. Right? With this thing here, we can say that they are more than 85%, right? So again, so given this thing here, now if people say statistically speaking, right, and they give you a bunch of number, you say, well, what is the p-value under that statistically speaking, right? So you can see, do you believe what they say, right? But again, looking at this thing here, this is the idea, and hopefully you guys see that the process, the procedure of 8.1, 8.2, 8.3, 8.4 is very identical. Is the same procedure. It's just a different testing. And now those are the 3 items that you will use in your calculator, which is the z test for 8.2, when they have a population standard deviation, a t-test for 8.3 if they have a sample standard deviation, and a one prop z-test for 8.4 when they ask you for a proportion. Okay, but again, the result, the decision, and how to conclude is the same. Question with this particular problem here? Any particular question with this item? This problem is a little bit hard because they don't